Alright, g'day, I'm Zach from Rising Sun FPV, and today we're going to be doing the BFW Beast Class electronics build component. So today we'll be doing the 6S Beast Class of the BFW frame. We'll be using the 80 amp advanced power drives ESCs. We're using the 360 amp PDB. We'll be using the Radex flight controller, and then the Team Black Sheep componentry, so such as the VTX and the receiver as well. And we'll use the Phoenix V2 from RunCam as the camera system. So we'll use that. Motors today for the Beast Class, we're going to be using the X-Nova 4808 700 kV motors from X-Nova there. And we'll be using maybe the Gem Fan or the HQ props, depending sort of what sort of flight performance we want. So you should have already watched the BFW frame build video, and in that you would have noticed I said once you get to sort of this point here, this is when you can start your electronics build component, starting with the power distribution drive, the power distribution board, and then starting then to do the ESCs and all your cable lengths and everything like that, which we'll do now. So we'll get out the 360 amp PDB. So with your electronics, so we've got the 360 amp and we've got the 80 amp ESCs here. With the electronics, the easiest way that I find to do the build is I go through and tin the components. So placing all the solder on your pads that you're going to be using. Okay, and then it's just going to make it easier to then solder your actual cables into. So we'll go through and we'll do all that now. Okay, so we'll start doing the tinning the pads. So when I solder, I just use a bit of blue tack to hold the component in place and sort of off the platform, because you're going to be transferring a fair bit of heat. The 80 amps, a little bit easier to solder. Your 120 amp ESCs do require a fair bit of heat to solder, but I use the C4 tip with the TS100, and it does the job in probably the fastest amount of time. Okay there, so we've just done the large pads for the 360 amp PDB. So you don't want to do huge puddles, okay? It's just enough so that when you tin your wire on your tin your wires, that it's just going to sort of amalgamate together faster, especially when you're using sort of on a 12S build and you're using 10 gauge wire for the power pads. I find that those are sort of the hardest to solder, and they if you do tin your wires and all that thing, it's just going to go a whole lot smoother, and you're not going to get any shorts or stuff around, and you're going to be putting too much heat into the board, because that's also a factor that you need to consider. So just nice quick, boop, there you go. So I normally solder around 400. Probably not supposed to, but that's just the way that I've always done it, and I've never had an issue. So 400, just boom, boom. For the smaller, for your telemetry, signal, and negative, around about 360, 350 is what I normally solder those. But I do those all together at the same time along with the ESCs, and we'll go through that in a second. Okay, so now we've done all the larger pads, we'll move on to the smaller pads, such as the little ESC, the capacitor little pads, and then for the signal, negative, and the telemetry. So what you want to do, or what I sort of recommend, is get some double-sided tape, okay, and just place it down just about here. All right. What this does is it holds down the capacitor and stops it from wiggling and moving. The capacitor legs are very sort of thin, okay. They can snap over time just from pressure and moving it around, traveling and carrying your Beast class or your X class, and can cause them to snap. If they do snap, it's very hard to sort of tell without inspecting your drone every time before you fly, which is highly recommended. All right, and if you fly without one of the recommended capacitors, you have the chance of causing an overspike inside your system, and that can cause a whole lot of dramas, because it's happened to me. All right, and one little bit of tape can save you a whole lot of stress and drama. It also helps as well when soldering the capacitors on, to hold it in place, and then what you can do is you can bend the legs around. Okay, so you bend these legs like that and around and put them into the slots. I've already put a little bit of tinning of solder on top of the pads, and then what I do is I'll push the legs actually inside that slot and then hold my soldering and push the solder into there to ensure it's got a nice stable connection. And then once I've done that, I'll just cut the bottom of the legs off to the actual capacitor, ensuring that I don't damage any of these components underneath here, which is also going to cause you dramas. So on the advanced power drives ESCs, you have a reverse pad. All right, so there's two pads, and it'll have REV just near the LED and that kind of thing. I don't solder this until it's actually on the drone, and then I figure out the motor direction. Okay, and then once I've sort of armed the drone, and then I can figure out what I need to reverse in that. So these ESCs and the 120 amp ESCs and the 40 amp ESCs won't work with BLHeli-S or BLHeli-32. They use their own software, okay, that you can solder on a USB device to go through and then change some settings in the firmware update, and then also be able to then use your RPM filtering on your 80 amp. I don't think it's been released yet for the 120 amp for RPM filtering, but I just use Betaflight 3.5.7 on the Radex, just because it just works really nice with X Class, and I've already got the tune locked in for it, so I just use that. So once you've got your legs all sort of cut and pushed into your little slots, just go through and solder all those up. Just be careful with the soldering iron tip that you don't touch the side of the ESC. All right, this can cause sort of like this clear leaching liquid to sort of it just doesn't work, and your soldering just makes it so much more painful. Okay, so once you've got all your ESCs and your PDB then soldered up, what you want to do now is get your power wire for your ESCs to PDB and your signal wires. So for sort of 6S, around about 14 gauge is good for the connection. If you want to go heavy duty, 12 gauge, okay, is also sort of good. So you place your PD down with the arrow facing forward, okay, so with all the motor pads actually at the front, okay, so the rear of the frame is denoted by the bump, okay, and then from there what you want to do is just get your cables, okay, and lay your ESCs out so that you sort of, this pad here, okay, being your power pads, positive and negative, are just sort of in line with the standoff bump, okay, and then run your cable, okay, length, and just cut it, twist it, tin it. Alright, so for all your cables, same for your ESC and signal wires. I solder the ESC and signal wires on first, okay, and then what I do is I get it, and then I just twist the ESC, okay, several times, alright, and then I sort of lock it in place with the power cables. Alright, this makes it a lot easier, alright, so when you do solder, and I've done it before where I've twisted the 3 wires before, so your signal, your telemetry, and your negative, I've twisted them, and then trying to solder those 3 when they're already twisted, it's achievable and you can do it, but it's a pain in the ass, and I just find it a hell of a lot easier just to solder them singly and then just do your twists after. if you're going to do the twists, and the way that I do it is make the cable a little bit longer, okay, so that when you actually do the twists, all right, what you want to do is the twist will then sort of bring that ESC in closer to the PDB. So essentially it will sit like that. All right, so I pull the cable back to around here, all right, and then enough twists will bring it into here. Okay, so that's all your signal wires, and you know, the negative and telemetry all soldered up. So, you know, realistically, you want your ESCs to be sort of, you know, that far out, so that when you do twist them, it does bring them in to sort of here, so that they fit really nicely and they're twisted inside the ESC holder. All right, so you want to twist them. So in the APD manual, it just states that if the cables, I think that was at 11 centimeters, if it's any longer than 11 centimeters, you're going to start having dramas. Okay, and then twisting the wires also helps with voltage spikes and ESC desyncs. Okay, so it helps to mitigate those, so you don't have them. For this build, this is going to be a 6S build. Okay, so realistically, you don't have to run your telemetry ESC wire if it's 6S. I'm building this just to show how you can build a 6S or 12S. Okay, so if you're building a 12S X class, run your telemetry wires and to your PDB, and then using the telemetry pad on the PDB, run that to on Radix, for example, it's UART 4. Okay, for your voltage to then show up inside your OSD. Okay. Because you can't do the highest voltage sensor is 8S on the Radix, okay, and obviously 50 volts is gonna it's gonna fuck it up. So we just run the telemetry, so you can see how much battery you've got all set up. You will have to go through and set ESC inside sensor ESC telemetry as one of the sensors, and then inside on your configuration page. On Betaflight, you'll need to choose that you're using the ESC sensor, and then also inside your battery configuration page, you'll need to choose the ESC sensor. As soon as you do that, and if you have a battery already plugged in, you'll see that it's already good to go. It finds that you don't have to really do any calibration for the main voltage, but as soon as you want to display for a 12S drone, you want to display average cell voltage and all that kind of thing, that thing's going to be blown out. And then same for milliamp hour, that's going to be blown out. Realistically, I only use on my OSD the name, I use a barometer to help me land, and the voltage of the main drone itself, so then I can see how close my batteries are to just going as well, because I've killed so many batteries now. So what we'll do now is we'll do the ESC power cable. So we'll go through, we'll twist up all the ESCs, okay, and then we'll measure. Ensure that you leave a little bit of slack, okay, so you don't want it super tight, because remember that you're going to be bending these things down just like that, okay, so you don't want to have the super tight, you want a little bit of slack in there as well, so that when you do crash, you've got a little bit of movement. We've seen, how many BFWs have we seen now crash? Around two personally. I've crashed mine probably 3-4 times now, so we have crash tested them. The electronics have all survived. The arms are a different story, but it's about a 10-minute job to replace your arms. All right, so let's start that now. Alright, so we've gone through and we've soldered on the ESCs to the PDB, alright, and we've just got that loosely on there. next thing I'll do is solder on the flight controller. So I just use the plug, just in case I do need to take off the flight controller, to then take out the SD card for black boxing or anything like that. Just find it easier to use the plug, and the brain Red-X plug is nice and snug in there. If you do want to make sure it's nice and secure, just a dab of hot glue on the top between the actual connector and the port. Will hold it in a little bit firmer, but I've never really had any issues with it on a hard landing. So I run the 4 signal, okay, then your 5 volt in, okay, and that's coming from 5 volt from the PDB, okay, so that powers your flight controller. And then I run this green one here, which I then put in, is UART 4, okay, which is the ESC telemetry. So I'll solder that to the telemetry pad. So I'll go through and solder all those ones in now. Okay, so we've completed the sort of central hub, so all the electronics are in there and attached. The next thing that we're going to start on is the motors. Okay, and the first thing that I start off with the motors is the MT60 connectors. So the MT60 connector is a connection between the ESC and the motor wire itself. Okay, so just these ones here, little 3-pole connector. Alright, goes together like that. Alright. So you put your wires on there from your ESC to this connector here, okay, and then you've got this one here from your motor to the connector. The idea of this connector is in a crash, that when you do crash and you snap an arm, which we haven't snapped one yet, we've only just bent them. The idea is that this connector will come apart, okay, and pull apart, and it will save your ESC so you don't rip the pads off the ESC, or even worse, ripping the actual wires out of your motor and costing you a motor depending on how where the tears happen from. So these are available in the store for around $6 for a pack, but they'll save you, like $150 component or a motor. So I recommend them. I use them on all my builds. I think all the boys are, and theirs as well. So definitely something to pick up as well. The other good thing about them is if you do need to replace an arm, it just makes it for a super simple connection. Essentially, you just unscrew your actual motor off your arm, okay, undo this connection here, and then slide the arm out of the actual drone itself, of the hub. Alright, put the new motor on to the arm, and put the new connector in, or put the connector in, and then off you go. So I think arm changes are taking us around about 15 minutes, 20 minutes, just from the way that we designed the frame. We wanted it to be sort of really fast. And the idea is, so I'm building a Beast class now, but if I wanted to run in an X class event, I can easily just swap the X class arms out, okay, and then go from there and do that. Alright, so now we're going to do the motors. Okay, so with the motors, you attach the motors to this plate first, okay, with the M4 press nuts in. I use Loctite on my motors. I just use the removable thread locker one. put all 4 of those on, and then mount your motors to your arm, okay, and then mount the arms to the frame, pretty much build the frame up. And then the last part is cutting your wire to the length for the other MT60 connectors. So we'll do that now. Alright, cool, so we've got all the TPU on now, we've got the MT60 connectors, we've got everything locked in and done. So here it is, the BFW Beast class frame with the 700 kV X-Nova motors on it for 6S. So some other little tips is with the advanced power drives, if you're really going to be pushing it and quite heavy on the throttle and smashing it around, I recommend adding an extra capacitor, okay? When you add an extra capacitor, alright, what I've done is in this space in here, is I just run the capacitors into here, okay, and they're fine, they're good to go for that purpose, just in there. I get some sort of 14 gauge wire, push the capacitor leg into the wire, solder it up, bit of heat shrink over it, and then solder it onto the pads, or you can just direct solder the leg straight onto the pads. Do find that this way though, your little knocks or anything like that, or even just transporting it, can actually snap those legs because they are a small bit of wire, and just constant bending and that kind of thing can cause them to snap. But hey, you're supposed to replace your capacitors after every, 30 flights. So if you want to know more about the capacitors, check out the blog post on Rising Sun FPV, along with the other blogs like lipos and props and soldering and all that kind of thing as well. So for that, there's the Beast class in the grey. I think it's the first one that we've done in the grey.